This video is continuous to file and directory permissions part 1. This is the part 2. When you create a file, its group is set to your primary group. If you are a part of multiple groups, for example, you are a part of Linux, DevOps, sales group, and many other multiple groups. If Linux is your primary or first group, then when you create a new file, it will be in the Linux group. It will automatically add to the Linux group. If you want to change the group of your file, you can use the command chgrp. Now I just wanted to create a file, f file 1. And before this, sorry, let me show you the default group. Here, for all the groups, we have Vasundhara as a primary group. And for file 1 also, it should come primary group as Vasundhara. Because, see, here Vasundhara is added. This file 1 is under Vasundhara. Vasundhara is the primary group. Whatever, if you want to create another file fr, then the fr group also will going to add to the same group, because here the Vasundhara is the primary group. Now let's see how to change the group from this Vasundhara to other groups. Let me show you how many groups exist. These are all the groups exist here. So I want to change from Vasundhara to Linux. So for changing, we can use the command as chgrp is a command, and the group name to which group you are going to change, and followed by the file name. Here I'm just giving file 1, and click on enter. Let me see whether the file 1 has been added to that group or not. See, from previously it was in the primary group is Vasundhara. Now the primary group has been changed to Linux. So instead of keeping files in different people's home directories, maybe you can have a common place to store all these files. You can move all the files to one directory path also. So let's look at the directory permissions again. Permissions on a directory can be affect the lines in the directory of a file. Not having a proper permission can prevent the execution of a file. If you are sure, then the file permissions look correct, they are proper. Start checking directory permissions, and also start checking the parent directories, and work your way up to the root towards the root of your file system. Let me clear this. Let me go to the, let me show all what are the directories and the files present under this directory. So under this directory, we have this link, files, and directories. Now I want to execute this file and show you. See, when I execute this file, it was executed and it throws an text, because here the user have an execute permission. User and others will also have an execute permission. Because of that reason, I'm able to execute the command. Now I want to change the permission on cat file by using chmod command. Chmod 400. Here 4 means, as I mentioned in previous videos, for read, write, and execute, we have a numerical values. For read 4 and write 2 and execute 1. So I'm just giving only the read permission for the user, and for others and for groups, I'm not providing any permission. And followed by the file name, click on enter. Let me see what permissions have been allotted. The only I have provided only read permission, and it have updated accordingly. Let me run this command. Let me run this command. Yeah. See, it is throwing an error as permission denied because previously the cat file have execute permission for all others and users and groups. Now I have removed all the permissions. I just given the read permission for the user. So that's what it was displaying an error permission denied. Now I'll give this file permission as 500, which means 4 means read plus 1 means execute. I'm just giving the user to execute the command. Click on enter. Let me run the same command. See, the command has been executed. Right? File creation mask. File creation mask is what determines the permissions a file will receive when it's created. If no mask were used, then the default permissions would be 777 for directories and 666 for files. The file creation mask is typically set by system administrators to same default. However, it can be overridden as per the user's requirements by using this umask command. The umask command sets the file creation mask to the mode that you pass to it. If you use hyphen capital S, that means umask will be displayed and accept the symbolic notation. The modes applied to umask works in the opposite way. As a mode given to chmod, so when you give chmod 7, that means read, write, and execute permissions are all permissions. However, when you give 7 to umask, that is interpreted to, which means no permission or all permissions off. It totally acts opposite to the chmod. So you can think chmod is giving adding permissions while umask turn off or subtracts or takes away the permissions. A quick way to estimate what a umask will do to the default permission is to subtract the octal umask mode from 777 in the case of directories, and in the case of files it's 666. For example, let's take an umask as 022. If we subtract this 022 from 777, we get a permission as 755, which is fine. And for files, when we subtract from 666, we'll get an output as 644 file for files. If we use mask as 002, then we'll have a default permissions for directories as 775 and 64 for files. Using a umask of 002 is ideal for working with members of your group, since the permission allow members of the group to manipulate those files and directories that you create. You can modify the files also, right? Yeah. Again, this method of subtracting these permissions is an estimation. So here an example of umask where this breaks down a little bit. So umask as 007. If you subtract from 777, we get 770 for directory permissions, which is fine. However, 666 minus 007, which when you subtract these two, which throws a negative 1. 6 minus 0, which is fine, 6, which is fine, but 6 minus 7, which is a negative 1. So there is no negative permissions, there is only no permissions. So it breaks down a little bit, but it gives good idea of what to expect. So we just expect there are no permission for this. Here are some fairly common UMask modes: 022, 002, 077, 007. This table contains all the resulting permissions created by each and every one of 8 UMask permutations. Here, the binary and the octal value represent zeros, right? So no permissions are provided. Now, when the octal value is 1 and the binary value is 001, because here we are just giving the execute permission. One means for read 4, sorry, for read 4, for write 2, and for execute 1. So here I'm giving 1, right? So only the execute permission will be given to the file. Coming to the directories, it will be access permission. Now when I for octal, it is 010, which means write permission is the value for the write is 2. So I'm just giving the 2. So accordingly, these all permissions are given. See, for 7, all the permissions are given, right? So for user and for the group and for the other. So which was mentioned 111. Read, write, execute. Here we have just mentioned read and write side. So the binary values for R is 110. If you run umask without any arguments, sorry, if you run umask without any arguments, it will display the umask in 4 characters. Instead of three that we have, instead of three, it will display 4. We have been working with the 3 characters we have been working with represents user, group, and others, as you know. However, there is one other class, and in this class, it is considered special modes. These special modes are setuid, setgid, and sticky. Just know that the special modes are declared by prepending as character to the octal mode that you normally use with umask or change mode. So the important point you want to know that umask 0022 is same as 022, and in change mode 0644 is same as 644. We are just explaining this to be aware of these special modes. They exist, and second, they are the reason why umask is displayed in 4 characters instead of 3. Let me show all these. So now I just want to create a file, umask, sorry, a directory. I'm by using mkdir command. Now I'm just changing my directory to test umask. Let me see what the value has been provided for this umask. Click on enter. So 0002, which is equals to 002. Let me show you in numerical, sorry, in symbolic. In read write execution permissions, and for groups read write execute, and for others only read and execute, which is opposite to change mode. In previously we see 0 means read write ex. Now let's see what default permissions are modified. Let me create other directory dir1, and then I also want to create a file. Touch is a command which used to create a file. I think you know. ls space hyphen l. The a file and the a directory one, these two are created. with the permissions 7, 7, and 4 plus 1, 5. 7, 7, 5. And the file permissions are 6, 6, 6, 4. Now, I'm just removing this directory, dir1, and file also, a file. So I have just removed. Let's change the umask value to 007. Let's see how it works. Umask 000, which is same 0007 and 007 is same. And click on enter. Let me see whether it has been see. 007 has been changed. Now I want to create a new file, new directory in the new file. Sorry, it just made a mistake. Rmdir not mkdir is the command for creation, and touch is the command to create a file. Okay, let me see. Before it was for others we have provided execute permissions, but for now for a directory execute permissions are removed for only user who is the owner, and for groups we have provided execute permission for directories. And for file coming to file permissions, we have just provided read and write for users and group, and for remaining others no permissions, which means here the 7 only provides for group and the users for the directories, and the for files only read and write. Permissions can be represented by symbolic or numbers. The effect permissions have on directories slightly different than files. We talked about how to change the permissions with chmod command, and we talked about some strategies of working with members of your group. And finally, we covered the file creation mask and the umask by using the umask command.